let's move on to the surface area of a frustum. Let's understand what is a frustum first. If a cone or a pyramid is cut through a plane parallel to the base, unaikata, the top part forms either a smaller cone or a smaller pyramid, and the bottom part forms what we call a frustum, something like this. And for us to be able to understand how to deal with frustum, a frustum can either be obtained from either a cone or a pyramid. Now, for us to be able to understand the surface area of a frustum, of course, we are borrowing it either from the surface area of a cone or the surface area of a pyramid. But of course, we have to start by having the knowledge on how to complete. If the frustum is from a cone, definitely at one point we have to complete it for us to be able to calculate the surface area. By doing this, I will calculate the surface area of the bigger cone, of course with the imaginary top, which I'll place there myself or complete it, minus the surface area of the smaller cone from the top. Whatever I'll be left with is the surface area of a frustum. When it comes to frustum, there is something again which you have to bring on board. You have to understand something on similarity. You have to bring on board the knowledge on similarity, because if I'm given the bigger radius and the smaller radius, and of course I've been given either part of the height, either of the cone or the frustum or the cone, then when I bring on board the knowledge on similarity, I'll be able to calculate the missing value. So we normally say the big radius over the small radius should be equal to the big height over the small height. So this one is very important for us to be able to work out with frustums. For example, find the surface area of a frustum whose top and bottom diameters are 30 centimeters, 20 centimeters, and 30 centimeters, and it has a height of 12 centimeters. Of course, I've drawn my frustum here, which personally I've completed. I'll put the information given. The top diameter is 30, so I'll take the radius to be 15. I mean the bottom diameter is 30, so I'll take the radius to be 15. The top diameter of the frustum is 20, I'll take the radius to be 10. The height of the frustum is 12. Of course, I have something here missing. Are we there? And that's why I was saying, at this point now, we require the knowledge on similarity. We have to complete this. If I want to calculate the height, which is missing, I'll come and say, it will be the big height over the small height equals to the big radius over the small radius. Now, what is the big height? The height of the whole cone will be given by 12 plus the small height over. What is the height of the smaller cone? Height h equals to the big radius is 15 over the small radius is 10. From there, I have now 10 into 12 plus h equal to 15h. Are we there? And from there, of course, we have 120 plus 10h equal to 15h. So 120 equals to 5h divided by 5 divided by 5. The smaller h will be, what is this? By 5, it gives me what? 2, because of it will be 24. You see, now I've been able to calculate the smaller height. So back to the question. Now, I was doing that so that you don't ask me where am I getting 24 from. So in this case, I'll come back to the surface area will be given by pi RL. This is now the curved surface of the big cone minus the curved surface of the smaller cone. I want you to take note. There is a difference between an open frustum and a closed frustum. In this case, this is an open frustum. That's why you find the surface area. I'm not interested with the area of the base and the area of the bottom. So it will be 22 over 7 times. Radius of the bottom is 15 times. Now, this 39, you might wonder, where am I getting that 9 from? With my 12 plus my 60, was it 60 with my 24? Then I have, if I want to get the slant height of the bigger cone, I will use 24 plus 12. That gives me 36 and 15. I have 36 and 15. 36 squared plus 15 squared square root. That one leaves me 39. Are you there? Minus 22 over 7. I'm now going to the smaller cone. Times the radius is 10 times where is 26 coming from. I have 24 squared plus 10 squared square root. I'll get 26. Because here what I need is the slant heights, not the perpendicular heights. But I have to either marry all of them to get the answer. The first one gives me 118.39.57 minus 817.14. Then I remain with 1021 centimeters squared. That gives me the surface area of a frustrum which is open. Are you there, class? If the frustrum is a solid, then the surface area will be, on top of what I've done, on top of the surface area of the curved part, this part now, which is curved, I will be forced to add the area of the base plus the area of the top to end up with the surface area of a solid cone. So in exam, take note, check whether the frustrum is a solid or an open frustrum. Thank you.